Okay, good day everyone. I'm Mr. Goson and today we're gonna talk about active transport. So before that, I want to state first the objective for today. So the first is to explain transport mechanism in cell such as active transport and to differentiate exocytosis to endocytosis. So those are two objectives for today. So before that, let's have a little recall of the past lesson, which is passive transport. Passive transport is the type of cell transport in which the substance moves from a higher concentration into a lower concentration. So now, we're going to talk about active transport. Active transport, it moves substance from a low concentration into a higher concentration. Can you see the difference? In passive transport, we have movement of molecules from higher to lower concentration, while in active transport, molecules are moving from lower to higher concentration. So they are exact opposite of each other. And another difference from them, passive transport, since they are just moving from higher to lower, it is easy. You don't need energy from that. For example, diffusion does not need energy, while in active transport, you need energy. So that's one difference of active transport and passive transport. Active transport needs energy in order to do that. And what energy does active transport need? So the energy that it needs is what we call ATP. I know that you already heard that. ATP stands for adenosine triphosphate. So adenosine triphosphate is made of adenosine molecule and 3-phosphate molecule. Hence, it is called adenosine triphosphate. Okay, so we have three types of active transport that you need to know. We have membrane pumps, we have endocytosis, and we also have exocytosis. So we're gonna talk about that. So first one is membrane pumps. In active transport, since it requires energy and it's like forcing the molecule to go to lower to higher concentration, we need something to, it's like to force it, to push it to go to that area of concentration. So that's why we have membrane pumps. Membrane pumps are made up of special type of protein from the cell. Okay, so one example of this is this sodium potassium pump. Okay, so we have potassium, which is K, the chemical symbol from it, and we have sodium, which is Na. In sodium potassium pump, here's what happens. We call chemical gradient. Chemical gradient is the tendency of the molecules to move from a higher from a higher concentration to a lower concentration. Because for in analogy, just like in real life, diba? If you're from in a crowded area, what do you want to do? Oh, that's right. You want to go to an area that is not crowded, because if it's crowded, it is hot, it is messy, and we don't like that. So molecules somehow they behave the same way as we do. They tend to diffuse, to move further away from each other. So that's why, for example, you have a glass of water, then you put food coloring on it. Or what happens to the food coloring? The food coloring will spread throughout the whole water inside the glass, diba? So that's how diffusion works. And you don't need energy from that. You don't need energy from that, because that is passive transport. So in here, in active transport, why do you need energy? For example, here I have a diagram. For example, we have food coloring. Just like what I'm explaining earlier, we have food coloring, let's say 50 molecules of it, and as a channel opens, can you predict what will happen? Okay, due to its tendency of its chemical gradient, or to move things from higher concentration to lower concentration, the molecules will come inside or will go outside the membrane, will pass through the membrane. Not all of them will go inside or outside the membrane or will pass through, only half of them. So the chemical gradient begins to shrink as soon as the channel opens. And it turns out in the end what happens is we have 25 molecules at the bottom and we have 25 molecules above or inside or outside the membrane. So this is chemical gradient. It turning things to, it balancing things, okay, from high to low, is continually spreading it equally. So we have an equal balance of concentration inside the cell. That's how chemical gradient work. But another thing is molecules has an ion, okay, meaning it has a charge. So we have two types of charges, right? Positive and negative charge. So for example, in those sodium potassium pump, when inside the cell we have two types of molecules, sodium of course and potassium. So the difference is sodium and potassium have different charges. So for example, in sodium potassium pump, let's go first to potassium since both of them has positive charge. We have here potassium chloride, okay? We have KNCl. So potassium has positive charge, while chlorine on the other hand has negative charge. So what happened here, inside the cell is removing potassium. As the channel opens, only potassium or sodium can go outside that membrane, can pass through that membrane, and all these chlorine molecules will just stay inside. So what happens here is, first we have a balance concentration since we have positive and negative. They balance each other. When the potassium goes out of the cell, it creates a different charge inside and outside the membrane. So as you can see, since only the potassium can only go outside the cell, it creates like a positive region, a positively charged region outside the cell. Since all of the molecules outside the membrane is potassium, and potassium is positively charged, so meaning it like creates a barrier or an area of positive molecules inside of it. So what happens here is, since as we know in the law of attraction, opposite always attracts, and like charges, they repel each other, they don't like each other. So what happens here, when there's enough charges or concentration of potassium outside the membrane, it kinda repels the incoming sodium that want to go out of the cell. So instead of they're just easily passing through the membrane, they are being repelled by the potassium outside the cell, since the potassium inside is positive and the potassium outside the region is positive also, so they cannot pass through. Just like an invisible force by applying the law of attraction. Now what happened in the potassium pump is, since it is already equal or there's already an equilibrium outside and inside the membrane, the phosphate in the ATP pump to the channels in the membranes in order to forcefully change its shape in order for the sodium or for the chlorine to go outside of the cell, while substance outside of the membrane can now go inside. So once it goes inside, it will become balanced again. We will have an equilibrium. So that's how sodium potassium or membrane pump works. So in analogy, in order to open the door, you must need to pay ticket. So that the ticket is the ATP. So I hope you are understanding my analogy. Okay, next is vesicle movement. We have two types of vesicle movement, which is endocytosis and exocytosis. Endocytosis is a process in which cells ingest external fluid or macromolecules or other large particles outside the cell. So meaning, Endocytosis is like a process of cell to eat an external molecule outside the cell or any particles outside the cell. So we have two types of endocytosis. First is phagocytosis and the second one is pinocytosis. So what is the difference between the two? Phagocytosis is the process of uh, ingesting large macromolecules or large particles, while pinocytosis, on the other hand, is ingesting fluids inside the cell. So, in other words, it's like phagocytosis is eating whole food, while pinocytosis, on the other hand, is the process of it's like drinking fluids inside the cell. So that is endocytosis. So the process of excreting or removing particles inside the cell is what we call exocytosis. So if we go by definition, exocytosis is a process by which a substance is released from a cell through a vesicle that transport it to the cell surface and fuses it with a cell membrane. So in order for you to understand on how do cells eat, how do cells remove particles from it, what happens is the cell membrane is changing shape. Okay, the changing shape in order to occupy or to release particles inside and outside the cell. That's what we have for the lesson for today. Now I have prepared an activity in order for me to see if you really learn something and if you really grasp the knowledge that I want you to impart. So the activity is you're going to make a Venn diagram. Are you familiar with the Venn diagram? Is two overlapping circles in which you will put the similarities in here in the middle part, and at the outside part of the circle you will put the differences between the two. So you will make a Venn diagram about active transport and passive transport. Another activity is give an analogy on how do active transport works. Then, last but not the least, in your DLP, I have prepared also quizzes like labeling and doing an illustration. So you need to pass it on my FB or Messenger. So I'm gonna wait until the next lesson. Okay, you need to pass it. Okay, so that's it for today. If you have any more question, just message me in Messenger or on any social media accounts. And I hope you're doing good today, and I hope you learned from today. So, so that's all for today. Goodbye, class. See you next time. Bye bye.